So now we're going to talk about areas, okay? And we're going to do areas of just certain figures here today. I'm going to give you all the formulas for them first, and then we're just going to start working problems. This is, again, should be a review of stuff you've had before. So let's just start real basic. The area of a rectangle. So if I have a rectangle, we call this the width, and this is the length. The area is length times width. Okay, that's easy. Now if I have a triangle, okay, with the triangle, we call this length on the bottom the base, so that's the side length, and then this length is the height of the triangle. That means how tall is that triangle, like from an altitude perspective. If I have the base and the height, then area is 1/2 the base times the height. If I had a right triangle, let's say it was a right triangle, that's actually a really nice triangle to have, because if it's a right triangle, if this is my base, then my height is just that side length, isn't it? Okay, so that would have the same area. All right, I'm going to erase that. The area of a trapezoid, I've got some trapezoid here. Let me fix that, make this look more parallel. Okay, this is my trapezoid. If we call this base 1 and call this base 2, so those are the two parallel sides. And then over here I've got a height of that trapezoid. What it is it's the area of that trapezoid is 1/2 base 1 plus base 2 times the height. Okay, so basically this is a formula for the average of the two bases. Okay, so that would be the area of what do you call it, a trapezoid. And then the last area we need is the area of a parallelogram of any kind. Again, we have a base, and then let's say we have a little height here of the parallelogram. The area of the parallelogram is just base times height. Okay? And I forgot there's one more. We need a circle. If I have a circle, we're going to do two things about it. And it has a radius. Circle has a radius. The area of the circle, so the amount of, is pi times r squared. And remember, pi is 3.14, whoops. And then it goes on forever, is pi. It's on your calculator, there's a pi button. Okay. Pi times the radius squared. Okay, so for example on that one, if I had a circle of radius 3, if r equals 3, the area equals pi times 3 squared, which is 3 squared is 9, so I could write this as 9 pi. I could also plug this as 9 times pi in my calculator and get a decimal. And that gets me 28.27 units squared. Whenever we're doing areas, we do square units, okay? So that's the area. We're also going to do something called the circumference. The circumference is the distance around the circle. So it's like the perimeter of the circle is what it is. So if I had a string that I set on this and wrapped around, how long would the string have to be, is what the circumference is. Okay, circumference is 2 pi r. 2 times pi times r. That's our circumference. Okay, so we have an area and a circumference. Okay, let's just start doing a bunch of problems and you'll start to get acquainted with how to use all these. Okay, let's find the area of these two figures. Let's start with this one here on the left. Okay. The area, this is the parallelogram, the area is going to be the base times the height. The base we'll call 58, and the height looks like it's 43. That is super easy, isn't it? I mean, this section, I think, and the last one are quite easy. So 58 times 43, that's 2494. And area is not in feet, it's in square feet, feet squared. Like if you think about in your living room, the amount of carpet you need is in square footage. The amount of baseboard you need to go around the edge is in feet. So the amount of baseboard you need is kind of like the perimeter of the room, and the amount of carpet you need is the area of the room. So square footage. So you always put a little square on the unit whenever you're doing area. Okay, let's look at the second one. So the area of a triangle, this is a triangle. Whoops. So the area of a triangle is 1/2 base times height. Well, if we use this as the base, the height would be this thing right here, since this is a right triangle, right? Well, we got to use Pythagorean theorem to find the height. We'll call that h, right? So we know that 8 squared plus h squared equals 10 squared. So that means that 64 plus h squared equals 100. Subtracting the 64 over h squared equals 36, so h equals 6. So my area is 1/2 the base, which is 8, times the height, which I just found, which is 6. 1/2 of 48 is 24, and then it's meters squared, square meters for area. Okay, let's do another couple problems. Okay, let's find the area of these two. We're going to find the circumference of the circle as well, or the perimeter of it. So the area of this first one, this is a trapezoid. Well, a trapezoid has an area of 1/2 base 1 plus base 2 times the height. Okay, so that would be 1/2. Base 1 is that one. Remember, the two bases are the two sides that are parallel to each other. So that'd be 20.8 plus base 2 is 10, right? Times the height, which is 7. Okay, let's plug this into my calculator. So I do 20.8 plus 10. Then I multiply it by 1/2 and 7. And it looks like I get 107.8 square meters. Meters squared. Okay. So area in this one is pi times the radius squared. Well, this is not the radius, folks. This is the full diameter, right? This is the diameter. Diameter is the full distance across the circle. We want the radius. Well, if the diameter is 40, the radius is half of that. So the radius is 20 in this triangle. So make sure you don't confuse diameter and radius in these problems. So this would be pi times 20 squared, which is pi times 400. So if I do that on my calculator, 400 times, and then hit the pi button, I get 1,256.64. I'm going to round that, actually. Let's round that. 1,257, if I round it, square feet. Okay. And then the circumference is 2 pi r. So that's the distance around. So that'd be 2 times pi times 20. So that's 40 times pi. 40, let's just do it in the calculator. 40 times pi is 126 roughly. And that's going to be regular feet because that's distance around. That's the length of the string I'd need to form that circle. Okay, it's the perimeter. So perimeter is always in the unit, and areas in the unit squared. All right, let's do a couple more that combine some ideas. And your Easter egg, by the way, at this point, okay, I'll do the Easter egg. It is 329185. 329,185. Okay, let's find the areas of these figures. These figures have some different parts we could break them up into. So what I would do in this first one, honestly, there's a couple ways to do it. Probably the easiest way to do this is to break this into two rectangles. Rectangle 1, we'll call it rectangle A up here, and rectangle B. See that? So the area would be the area of rectangle A plus the area of rectangle B. So the area of rectangle A, well, we know the length is 3. So what's this width right here is the question mark. Well, the width looks like it's going to be 5 plus 2, doesn't it? So that should be 7. So this will be 3 times 7. And the area of B looks like it is 9 times 2, right? Length times width there. So this is 21 plus 18, which is 39 square feet. All right, that one wasn't too bad. Now, this next one looks like if I drew a straight line right there, I'd have a trapezoid. So I have an area up here that's a rectangle, and I have an area there that's a trapezoid. What's tricky about this is I want to cross this out. The reason I want to cross this out is because I want to find out what these each individual distances are. This one and that one. Okay. Well, I know the whole distance is 10, and I know that this one is 3, right? Just because over here it's parallel to that. So what would be left down here is 7, right? Because the 7 and the 3 have to add up to the 10 that I had there that I crossed out. So that's going to help me here. So my area, again, is going to be the area of the A rectangle plus the area of the B trapezoid. Okay, so area of A rectangle looks like it's 3 times 6. Area of B, well, that'd be 1/2 base 1, which is 9, plus base 2, which this is base 2 right here, right? Well, that's 6. It's parallel to that distance, right? So it should be 6. All times the height. Since this is a right angle right here, the height would just be 7 of that whole thing. So this is 18, and then 9 plus 6 is 15. So let's do this in the calculator here for a minute. So it'd be 15 times 7, 52.5. And that gets me 70.5, and that's square centimeters because it's an area. All right, let's go to the next one. And in this one, we're going to find the area of this, but we weren't given numbers, so we're going to have to leave the area in terms of A. Okay, so let's first find. So we'll call this area A. We'll call this area capital B, and we'll call this area C. So the total area is going to be the area of A plus the area of B plus the area of C. All right, so let's first notice here that the radius of each of those semicircles on top is A. So the area of, that means that each of these little distances here, I'll do them in orange, each of these little distances is A, isn't it? A, and A. So that means what's this total distance right here? What's A plus A plus A plus A? 4 A's, right? So this is 4A. Okay. Notice that if I sum these two up, the two semicircles, don't I just get one circle? of radius A. So basically those two combined should give me pi times the radius squared, correct? Because these two, this semicircle and that semicircle together make one circle. So they have one circle of area. Okay? And then I'm going to add the area of C, which is length times width, which is A times 4A, right? A times 4A. Take the length times the width. So this is pi A squared plus A times 4A is 4A squared. There it is. So that's the area of that written in terms of A. Now if we knew the number, if say A was 7, I could put a 7 in for A there and a 7 in for there, and I can actually get a number answer, but they're not asking me to do that. So this should get you ready for that homework in 10.3.